Hey, this is OXDF, and today we're looking at Advent of Code 2015, Day 9, all in a single night, and we're doing it in Rust. This is my journey to learn Rust after many years of hacking in Python, and we're doing it through the Advent of Code, and hopefully you're coming along for the ride with me. Let's take a look at the prompt for Day 9. So basically, I'm going to get given a list of cities. In this case, there's 3 in the puzzle input. There'll be more, and they ask me to figure out the shortest distance to visit all the cities. And so for 3 cities, you get 3 factorial possible routes. So that's 6 possible routes. And then you come across here and you can say, well, 605 is the shortest one to do. And that's the answer in the example. So they want me to do that for my puzzle input. If you're just joining me for the first time, I solved these in Python years ago, but I'm going back and doing them in Rust now. So normally I would get the puzzle input right here. Instead, I get the answer. So we won't look at that. Let's take a look quickly here at the puzzle input itself. There's actually 8 cities. So one, Fairy Run goes to 7 more, then Tristram goes to 6 more, and so on down to just Alpha Centauri has 1. And that's because we can assume the distance from A to B is the same as B to A. So strategy-wise, what we're going to do, we're definitely going to start by looping through each line in the input and creating a hash map, which is like a dictionary in Python, which takes in a tuple of a city pair. So city A, city B, and then also city B, city A, and then returns the distance. We're also going to need to keep a list of the cities because we're going to need that down the road as well. And it'd be just annoying to try to recreate it from the keys of that hash map. Just easier to use a little bit extra memory. But once we have that hash map and that list of cities, we can generate the list of permutations, all possible orderings of the cities, and then we will go through them and just try them all. I'm sure there are some algorithms we could use, maybe Dijkstra's or something, where we could calculate a faster way through it. But for something as small as even 8 cities, we should be able to do it in very quick time, just as a brute force. So let's go ahead and jump over into VS Code. We'll use my Genday script here. If you're seeing this for the first time, I went over it in detail in my Day 0 video. I'll be sure to include a link to that. But basically, it creates a new package for me here. It gets the input.txt for me. It also creates a source here for me, and which just simply reads the input into a variable called data. And for some reason, sometimes it breaks my plugin, so I may fast forward, but I'm going to real quickly reset that. All right, and it looks like it's up and working now, so let's go ahead and dive in. So the first thing we're going to do for sure is we're going to say for line in, not lin, in data.lines. We're going to loop over the lines. And for each line, let's take a look at it real quick. We're going to need something where we split it in. If we split on the space, there's going to be 5 tokens remaining, right? The city, 2, the next city equals, and the distance. And so let's go ahead and do that. We're going to say let tokens equals line.split space dot collect, and that'll pack it all into a vector. And so you can see here we've got it's having a hard time recognizing what kind of vector it is, but we'll come back to that in a second. So now we can say let c1 c2 dist equals, and we'll open that and we'll do a little right there, and we can say so c1 is going to be tokens 0, and let's go ahead and make that a string, toString. C2 is going to be tokens 2 toString, and dist is going to be tokens 4. And now this is actually a string, but we want to convert that to an integer, so we'll do parse and then unwrap like that. And now we should be good. Okay, so it's still really not happy about what's going on here. Let's go ahead and it wants a type. Let's give it a type. So it's going to be a vec of strings like that. So now if we save that, now we're looking better. What doesn't it like here? Consider giving it a type. Okay, we'll come back to that if it really struggles. But for now, we're going to go on. So now we've got C1, C2, and distance. So we're gonna make our hash map. So let's come up here. Let's see. We'll come up here. We'll do use std collections hash map, and we'll come down here and we can say let routes equals. It's not routers, just routes equals hash map oops, map new, like that. So we've got a new hash map. And now what we want to do down here is we'll do route dot insert. Now the key is going to be a tuple here. So we'll do C1, comma, C2. And then the vector, or the value, is going to be dist, like that. If we save that, it's pretty unhappy up here. Let's go ahead and, I guess we'll explicitly define this. So we can say hash map string, oh, map, like that. Does that make it happy? Sort of. Let's go ahead and make this a U32. And that's looking better. Now it's happy there. What's going on here? Oh, routes is not mutable. Let's make routes mutable. All right, and now I think we're happy. We'll grab this and paste it in again, and this time we're going to do from C2 C1, and that way, no matter which order we look it up in, we get back the distance. Now it's going to complain here. Let's see, it's complaining about using it after a move. So let's just come up here and we'll do a .clone. And if we save that, you can see the error on C1 went away right there. And we're actually going to do it down here as well because we're going to do something else too. So in addition to wanting this hash map of routes, we also want a list of cities that we're going to visit. And so I'm going to use a hash set here, like that. And and what a hash set is, I pulled this up on here. It has this really obscure sounding definition, but actually makes a lot of sense if you think about it. A hash set is implemented as a hash map where the value is null or empty. And so how does that make sense? Well, what we're trying to do with a hash set is make a set. And a set is like a list. In Python, it's a list, but you can only have things showing up once. And so, if you have a list of 1, 2, 3 and you add 2, you still have a list of 1, 2, 3. And so if you think about it, a hash map where we just care about the keys, is, the keys have to be unique. And so if we try to add one again, it just gets added again and doesn't change. And so that actually works really nicely for what we're trying to do here. So we will come down here and say, let not cities equals hash set new. So now we're going to make our list of cities. And the reason we're going to do that is because later we're going to want to create all the permutations, all the orders we could possibly visit, and trying to recreate that from the keys when we have these tuples is going to be just too much. So let's burn a little bit more memory and, just add them here. Okay, so now we just need to add the value, and the value is going to be C1. And, and we will do insert C2. So now, if we come down here, we can actually even do routes. Oops, didn't want that to be in. This probably is going to need a debug print. That, and we'll do cities. Again, probably going to need a debug print. And now let's give it a run. And take a look at what we got. So part 1, it's probably going to be pretty long, but we have these are all the different routes and distances between pairs of cities. And then for part 2, we have our list of cities, 1, 2, 3, 4, 5, 6, 7, 8. So that works nicely. And I think we're done with this part and ready to move on to part 2. Not part 2, but onto the next part. So we've done our prep. We've prepped our data into a way we can understand it easily. Now we want to do this loop. And I played with a couple different ways to do this. But I'm going to show you what I think is the most interesting one. We need to get the minimum distance, right? So let's just start with, we're going to start with something. Minimum distance equals, a lot. And if we get this back as our answer, we can say, oh, maybe we started the minimum too low. But I think that'll be fine. We'll say for route in, and we'll do cities dot iter dot perm. We don't have it yet. Okay. We need to include use, and this is, I don't know if I have this handy. Let's see. Where's my browser? Rust permutations. No, I've done this. Let's see. Here we go. Permutations in iter tools. So I think we need to include iter. Do it just iter tools? Give it a try here. let's try. Let's find something else that shows us. What I use, where's my, and then probably this one. Use iter tools, That'll work. Not standard library. Iter tools, iter tools. Now it might not, we're probably going to need to go here and update our cargo.toml to say iter tools. And we'll just be lazy and say, give me any version here. And let's save this now. And now our only complaint is that we're not using it, so that's good. So here we go. So we're back down here, and now we can do permutations like that. And now we need to give it a length of what we're going to be looking for. And so what we're going to be looking for is cities. Oops. .leng. Okay. So what we're going to have here, let's just talk this through again. We're going to go over, get all the permutations of cities, so all the possible orders where we take the full length and we return them. That's going to be 8 factorial, which is 8 times 7, 56. You know, it's going to be huge, but not, it's going to be big, but not huge, right? So a few hundred probably. I guess we could figure this out real quick. If we open up a calculator, see if I have this on here. What is 8 factorial? Okay, not a few hundred, 40,000. But 40,000 is not that many, so we can do that. So for each of these routes, what are we going to do? We're going to say let mut distance, we'll call it dist, to save us some typing, equals 0. And then we're going to say, oh, we got the min distance up here. We're going to say the distance. So now we're going to go through, we've got for each route. So each route is going to be a list of cities in a specific order. So we want to visit them that way. The way I liked doing this, I did it one way where I started with I equals 1 up through the length, and then I would get the distance for I minus 1 and I, and then like add them together. But I didn't like the way that felt to go over it that way. So I'm going to do something slightly different, which is let it equals route.iter, and that's going to turn route into an iteration object, an iter object. And so now I can say let c1 equals it.next.unwrap. Okay, so now we've got the first object. This, I don't know exactly why it's like a double pointer to this string, but we've got effectively this string. What don't we like about that? We might need to make this iterator might have to be mutable. Let's try that. Yeah, that's cool. Okay, so now we've got C1. So now we're going to say while let sum C2 equals it.next. So dot unwrap that. We're going to create a loop. And you can see we've got like a pointer to some unknown, but that'll be okay. We can say dist. Actually, for a second, let's just say, so we can see it, let x equals routes with an s, because we're going back to our dictionary now, or our hash map, dot get. And now we want a tuple in here, and that tuple is going to be c1 comma c2, because we got the 2. And let's just stop there. What that's going to return is an option. Now we're kind of unhappy here. Let's see. Oh, we don't need the unwrap up here, because there we go. So now we're going to get a string in here, double pointer, but I'm not okay, sure. And now we got this C1 and C2. And it says expected reference to be a pointer to a string, not a reference like that. So we're definitely going to put the pointer there. That's easy. Now it's unhappy with these. Expected string found pointer string, try using conversion method to string. Okay, it's not clear to me why I have to do this, but let's just follow the instructions the compiler gives us. Dot to string and save. And so now we're getting back an option with the U32. We don't want an option, we want let's unwrap that. And now we're getting back a pointer to a U32, and we can dereference that like that. And now we're getting back a U32. And so now we can say, instead of saying let, we can say dist plus equals, and we got it. I don't know if it's cooler to do it this way, but there we go. We've got our we're adding. So what do we just do? We're getting our C1. We then are reading our C2 in here. In as the next thing, we're gonna get the distance between them from our routes table and add it in. And then the last thing we need to do is we need to say C1 equals C2. So now, let's see, what are we gonna have about here? Cannot assign to us. Oh, let's make C2 mutable. Now we've said, oh, make C1 C2, and then we'll get the next C2 here and keep wrapping as long as there are more. And so that with that, we will have the entire, when this is done, we'll have the distance for our route. And so now we can say, we could do like an if distance is less than min distance, update it, or we can do something kind of like, yeah, let's just do that. That's actually easier. We'll do if dist is less than min dist, min dist equals dist. Like that. So now we've gone through, we've calculated our distance. If it's less than our minimum distance, we do it, and then we try the next route. So then we come down here and we just need to do min distance like that. And let's get rid of cities because we don't want that anymore. And we will run. And we get 117, which, if you remember, was the correct answer from the page. That's cool. Let's go down to part 2. And now Santa decides to show off, and he just wants the route with the longest distance instead. So this is going to be super trivial. Let's go in here. All we need to do is come back above our loop and here and do let mutable max distance equals 0. Because we're we'll start at 0, and then we'll say if dist is bigger than max distance equals dist. And so now we can come down here and say, whoa, it's getting kind of hangy here. Max distance. Let's run that with the release to make it go real fast. Oh, wait, download iter tools again. Not actually faster. Go fast. There we go. And the answer is 909. And we'll come back over here, and that is the answer. So we would get some stars in our puzzle. So some new concepts here. Hopefully that was interesting, and I'll talk to you next time. Bye.